So I guess a lot of you are already a bit familiar with eLabFTW, or at least have an idea of what it is. So it is an electronic lab notebook, so something where you can write your experimental records. I think I can skip the classical presentation. Yeah, you should read that. It's quite fun. I think I can skip the classical presentation about why you would need an electronic lab notebook. I think it's pretty well known now that it's important to be able to write all your data in a system that allows you to research it afterwards and to find it and to share it and to have collaboration and to simply upload the files and to do a search. And so, yeah. What I want to show you as an introduction is that eLabFTW is hosted on GitHub and has been open source from the start. And over the years, there was a good building of community users. And I think it's really a very nice thing to have a lot of people discussing on the issue tracker or on the chat. There are over 190 people on the chat or over on the discussions about the best ways that we can go to improve the software. And this is something I really enjoy to have a lot of different users coming from different fields and different countries with different backgrounds, and we can all discuss together about what is the best way to go with the software. So this is a bit what I would call community-driven development, where the users actually have a say in the direction of the software is taking, which is of course completely not the case for proprietary tools where you don't even get access to the source code and even less to the issue repository. So I will just show you quickly a bit what the software looks like. So generally, I put the language of the software in the same language I'm doing the presentation, but I just wanted to show you because I'm in Germany now remotely that you can get the full interface in several languages, and one of these languages is German, of course. And so I want to thank also all the people that participate into the translation of eLabFTW. So if you wish to, you can also do that. You can head over to PoEditor and start translating in whatever language you know. So let's go back to English. So the basic idea is that on one side you have your experiments, and so this is my list of experiments. I can also choose to show it in a more tabular view, so it would look like this. So some people prefer that, others prefer the default view, which is like this. Oops. Yep. So default view would look like this, and of course you can resize the stuff. And so on one side you have your experiments, and on the other side you have a database. And the database, so it's a very generic term, but it is generic because every team on the instance will be able to define the categories of items that they will find in their database. And so as an admin in a team, you can say, okay, so for instance, if you're a biology lab, maybe you will want to have some plasmids or some cell lines or some antibodies. If you're doing chemistry, you will have some chemical products and some I don't know, formal, whatever. And so the idea really is that you can define how your database will look like. So here, for instance, I have a macroscope category which I made bookable. And I also put a fiche de vie, so like a change log, I guess, about like, okay, I don't know if it was broken at some point, we can write in there that it was broken, and we'll show you later what is the JSON stuff and the extra fields. So in my database, then I have some microscopes, and these microscopes, I can book them, and importantly, I can also reference them. So here, let's just say, like I used the microscope Cezanne 1 Micro 2, so I just make a link like this. And the important bit is that this link that I made in the text automatically, it was made also here in this part of the experiment. And now on my experiment, I have a link to my microscope. And the important thing is that on the microscope, I also have a link to all the experiments that use this entry. So because of the really customizable everything on eLab, you can really achieve a good tracking of everything that you do in the lab. So in the database, you can have samples, you can have whatever you want, and then you use the linking system to link them to your experiment. And so then it becomes very easy to find all the experiments that use a particular product in the lab. You also have the possibility to link experiments between experiments. So that also can be a nice thing. Here in the uploaded files that I have, there are some files that are recognized by eLab. So for instance, DNA sequences are recognized, and then you get a nice map. You also have some files that are shown in 3D. And for chemists, you have the mol file, which is recognized and displayed. So this is not an image; it is an actual mol file. But eLab will show me the image, and with the mol file, if we go into edit mode, so there is basically a molecule editor, and you can load the mod file or draw some stuff. You can draw a reaction maybe and do something like this. Okay. I'm obviously not a chemist. And then you can save this as a special JSON, which would allow you to re-import it or save it as an image, and maybe why not insert it inside your text. And so here we have our beautiful image. So there are a lot of little features, and here I will focus only on a few of them because the goal, I mean, I've been asked to go more with the advanced usage of eLab rather than the basic stuff, but I think it's still important to at least spend 5 minutes on the basic stuff with all the visibility settings, where you can say, okay, I want these experiments to be visible by this team and this team, but also this team group and this team group, and also this user. You can also have read access for anonymous users, and you can have the same kind of complicated permission system for who can write on that experiment. Once your experiment is done, you can export it in PDF, in zip, in ELN, and I think I will now maybe talk about this archive format. So when I was in Germany, I spent 2 months in Jülich. I created, along with Stefan Brickman from Jülich, the ELN Consortium. And so the ELN Consortium is a groupment of ELN software, so ELN vendors, let's say. And we got together around the table to say, okay, so how can we improve the interoperability of our software? So this is really the I on the FAIR acronym, like findable, accessible, and the I is interoperable. And so we decided that we could have like a file format that we could then easily exchange from one software to another. And this file format would then contain everything about an experiment, a dataset, a sample, a protocol, a bunch of experiments, and everything. And so for that, we specified a file format, and this file format is based already on something existing. We didn't reinvent the wheel. We used the arrow crate. And so arrow crate is a research object crate, and it is something that exists for a bit of time now. And so it has already gone through several revisions, and it's quite a stable specification. But this specification doesn't work for an archive. And so we basically took the arrow crate and we said, okay, so this arrow crate now has to be in a zip file inside a folder, and etc., etc. And so this ELN file format, we started implementing it in our software, so in eLab and others. And recently, I was very happy that the ELN extension, the ELN media type, so media type is like the new name for meme types, the ELN is present on the official IANA media types. So this is like the IANA is the authority for a lot of stuff in the internet, and so now it's official. It exists, and so yeah, you have like this little thing that tells you exactly what it is and where to find information about it, and etc., etc. And this, in fact, was triggered by, I don't have the link open here, so Dataverse, GitHub. So you might know the data repository called Dataverse. So data repositories are something else than electronic lab notebooks. They are different kind of software, but in a sense, they are kind of the next step after you have your electronic, after you have basically your whole research data set, you want to publish, and generally now the magazine will ask you to publish also your data, to publish the raw data that was used for reaching these scientific results. And so it makes sense that along with this raw data, you would also add how you obtain this data. And so for that, this is the ELN. This is your lab notebook where you describe how you got the data and from where and all of that. And so I made this pull request to, and you see it was merged 12 hours ago, to start an initial support for ELN for file format. And so, of course, the end goal is that from the ELN, you export as a .eln file format, and you upload that to Dataverse, and everything is already there. Like it has your ORC ID, it has your name, it has the dates of when the data was generated, it has like the descriptions and the tags also, like a bunch of things that are automatically fed when you push your data. So yeah, this ELN consortium, I think it's a nice way to try and push better interoperability. And so I will continue to work with Dataverse. I mean, I guess Dataverse will be the first data repository that will probably support ELN. And then, of course, we can think about other data repositories in different fields, like Nomad in the field of material science. I'm also discussing with the developers over here. Maybe they are here in the room. But yeah, anyway, that's one thing that's nice. Another aspect of eLab, and that doesn't work for everybody, because some people, they will really stick to the basics of using the software through the web browser. But if you know a bit of Python, a bit of code, or whatever language, a bit of programming, you will be happy to find that eLab has a REST API. And so maybe that's more something for the dev talks afterwards, but I just want to say that this documentation of the API is generated from a file in YAML. So this is just a YAML file where I describe, okay, so for this endpoint, you can make a get, and this is the kind of answer that you will get. You can make a patch request with this or that thing and everything. And what is really nice with this Open API specification, so this is the standard for describing an API, and this specification will make a nice documentation like this. So that's great. But also something that I really like is that I can generate from that application a Python library. And so as you can see, the Python library for eLab has no code inside. It has just like a bunch of examples that show you a bit how you can do a few actions, but there is no code. There is absolutely no code. There is like one config file, and that's it. And I think it's really great that now we don't really have to spend some time coding stuff. You can just declare how we want things to be, and then there is a library that will take care of it. It's a bit like now, I'm sure you've heard about ChatGPT. We don't write code anymore or look on Stack Overflow for the stuff. We just ask ChatGPT, just write me some code that does this, okay? And most of the time, it's good enough. and that's okay, and we can use that. And so I think this is also like kind of an evolution of the code where we don't actually have the need to code stuff anymore. We can just rely on a library to do it for us. Another aspect that I want to talk to you about is the timestamping. So in the lab notebook, it is basically the first software, the software that is closest to the bench. So when you create something, when you invent something, you will put it into your lab notebook. And so it is important in some cases to be able to say, at this time, the data was there. It was like this. And so for that, you will want to timestamp your experiments. And what is timestamping? Timestamping is basically taking a picture of your experiment and signing it, basically saying, okay, it was like that. But if you are the one signing it, it doesn't count. It needs to be a trusted third party. And so for that, eLab is relying on a well-established protocol called RFC 3161. And this protocol allows the timestamping, the trusted timestamping of experiment. And so how it works is that you click here the little timestamp button. It tells you a bit what it is. Okay, you click timestamp, and now you have a timestamp archive. This timestamp archive will contain two files, a PDF, a special PDF, I would say, and the .asn1, so a binary file, which is like the proof, the token proof that is signed by the trusted third party. And this file cannot be modified, at least not by the user. Of course, if you're root on the server, you can do what you want, but it cannot be modified, deleted, or whatever. And if you have these two files, so the PDF and the token, you can prove that it was like this, at least at the level where you trust the third-party authority, of course. And so the PDF also will contain the changelog. And so in the PDF that is timestamped, you also have like the changelog of what happened in the experiment. And by default, the trusted authority is DFN, which provides a free service. But at least for a lot of users in France, we are using Universign, which provides qualified timestamps, meaning that they are regularly audited, and so they are more trusted than like a free service like Sectigo, DigiCert, whatever. And so it comes at a cost. So there are also other TSA, so timestamping authority out there, and you are free to choose the one that you wish. There are some that are pre-configured in eLab, but you are free to add a custom one if you want. So that's one way to timestamp your experiments, is to use the trusted timestamping, which is defined by the protocol RFC 3161. Another function of timestamping that exists in eLab is the blockchain timestamping. And so the blockchain timestamping works with the Bloxberg blockchain. So the Bloxberg toolchain is based on Ethereum, for those who know a bit different kind of blockchain you can have. And what I want to show you, is this, is that when you, so again, we get a zip, and inside the zip, we have two files. We have the timestamp PDF, and we have this research object certificate, which tells you, okay, so this data, so it's only a hash of the data. So same with the other mechanism. We don't send actually the data to a third party. We hash it and we send it. So a hash is a one-way function where you give it any kind of input and the output will always be the same. And if you change just one bit in the input, the output will be completely different. And so, yeah, this uses the Bloxberg stuff. And the Bloxberg is, again, a consortium of several different, or no, maybe they call it association, of a lot of different entities. And I'm pretty sure that in the audience today, we have people from universities or institutions that are part of this consortium, because a lot of them are German. We can see Zurich here, KIT, Max Planck, Frankfurt. I mean, yeah, I'm pretty sure you will find entities that you know, and a bunch of these entities also use eLab. So it makes sense to also use this idea that they have to use the blockchain to certify research data, because that's what we want to do. We want to certify the research data. And so that's one aspect, is the timestamp. Another aspect on which I'm working on is the authenticity, meaning we really want to be able to prove that not only the data was there, but also that it was made by this person. And so for that, the way we will do it with the CNRS, which will deploy eLabFTW in all the labs in France, and CNRS is the third largest research organization in the world. With the CNRS, we decided to go with strong authentication, meaning two-factor authentication with a physical USB key that would be assigned to a researcher. And so this researcher would log in with this key that would prove that, okay, it was this researcher, because we know we gave this key only to this physical human, and they log in with their password plus the key. And so if you couple that to the timestamping, you are really super good. If one day you're going to patent your stuff, and someone comes to you and they're like, no, you're good. But another also thing I'm working on is Kix, which is a technology that allows you to do. This guy doesn't seem very happy. That allows you to add inside your files a way to verify that the document has not been modified, basically, and that you can verify if it's coming from the person that they say it's coming from. And so one thing that is quite cool in their technology, which unfortunately is not open source, is that this proof gets inside the file. And so if you're familiar with GPG signing of the files, you know, like the signature is a file that comes is another file, basically. So you need to have two files. And here you basically put all of this inside the metadata of files. Because, you know, in PDFs, for instance, you can just put a bunch of random data in between the lines, I would say, and it works. And the same with a lot of file format, like, you know, in the JPEG, you have the EXIF, or you can put some metadata in there. And in most formats, you can just put some metadata in there. And so it's using a very cool technology to use that. And so my idea really is to work with them to try and bring this to eLab. It's already quite popular in I would say big companies, but let's bring it to the lab notebook world. So if you know, like Thales is a very, very big company. SNCF is the train system, and Enedis is the electric system in France. So you see that their clients are really big companies, but they are also very interested in developing it and using it in eLab, and they are also very cool people. So it's nice also to work with them, and they are French also. So yeah, I think timestamping, I showed you a bit all the different things you can do with that. There is also the possibility to log experiments, and so this can be part of a workflow that you can have with the people in your lab, where the PI, for instance, will verify the experiment and say, okay, so yeah, this is all good, and you can leave a comment, you can log the experiment, and so then it won't be modified anymore by the user. But if you're the one that locked it, you can unlock it, of course. But if it's the PI that locked it, you cannot unlock it. So another thing I didn't show you also is that there is a scheduler. So if you remember when I showed you the microscope, there was a little box to say that it was bookable, and the microscope, you can book it, and any kind of items basically in your database that you elect to be bookable, you can put it into the scheduler. And an interesting aspect also is that you can bind it to an experiment. So you can bind that booking slot to an experiment or to something in your database. And so here, for instance, this booking was bound to this experiment. And so we can see it here. In the editor, you can also add some code inside a special thing. And so you have a bunch of languages here. So you can put code snippets and they will have correct highlighting of the code, which is always nice. And you can also put some LaTeX code, and so it will look nicely in the text, and it will even work in the PDF, which honestly was difficult to achieve, but yeah, it will look good. To try and wrap this up, can also show you a bit the steps and the to-do list with automatic generation of the unfinished steps. But I realize now that I forgot to talk to you about the most important thing that I wanted to talk to you about, which are the metadata and the extra fields. So basically, when you have an experiment like this, you have a date, you have a status, you have a title, you have like a big block of text, you have some steps, some links, or whatever, some attached files, okay. But what if I want to have, for instance, an input that asks me for the wavelength or for the temperature, and I want this input to only accept a number? It would make sense for a temperature. And so for that, what I can do is that in here, I can add a field. So it will be an extra field. So let's try the temperature example. So there are different categories of things that you can have. And so here I will say temperature, description, the temperature. I think we don't really need the description. And there is no default value. And so it adds it in there as JSON. And so this is how we decided to go with how can the user define basically custom stuff. And so we went with a JSON colon in the MySQL database to define that. And so now here I have here an extra field, and I have my temperature, and I can say it's 27. Okay. And this extra field, I can now use the extended search with the extra field search to look for a temperature of 27. And it will find me the experiment with temperature of 27. Or I can look for all the experiment with a magnification of 20x and add another parameter like, I don't know, and a wavelength of 100 nanometer or whatever, you see. So it allows you basically to not only define extra fields that will be useful for the users to have, and with a little drop down also is very nice, because sometimes you only have 3 choices, and so it makes sense to have a little drop down, or to have an input which behaves as a date. And so you not only have this new input that you can have, but you also have a way to look for them inside the search. And the interesting aspect of these extra fields, of course, is to have it in your templates. And so once you define them in the template, after when you start your experiment, you already have your extra fields and your inputs that are present there. And we also even added a way to hide this main text, so you can end up with only the extra fields and not the main body anymore, if you don't want to let the user have like a free text input, and you really want to drive them to have something that is very precise in all the different inputs that you let them have. You can also choose to do that. So yeah, this extra field, it really started as a kind of an experiment, and it turns out that a lot of users really enjoyed it and started using it, and so now it's here to stay, and there are some new features that are added regularly.